Now I was playing with some blocks over my vacation that I just recently was on, and I was playing with some my younger nephews and nieces, and we were stacking blocks up like this, and it naturally came to working out how far we could stack them without the whole lot toppling over. As it turns out, this is actually quite an interesting problem, and one that's been talked about and solved, and indeed YouTube videos have been created for this. In fact, this is a good one here, which I'll put the link in. It goes for quite a long time anyway, and they do this by inspection. They do it by sort of experimentation. Here you can see kind of a leaning stack of blocks. But as it turns out, it's a really interesting mathematical problem as well. If you can look at some of these Wikipedia references, you see here that people have worked the problem. And it's actually part of even more, well, maybe even more, an interesting aspect of math for the harmonic series. All right, so harmonic series comes up many, many different places in nature and music and all sorts of things. And so then my problem with thinking about it that evening was, how can we build a nice Onshape model of this? And using some of the nice tricks and features in Onshape to do this the best way. So I'm just going to walk through it here. These blocks these individual parts here. Actually, the specification I measured. We had this big pile of bricks from some kind of Jenga system, so we're using that. So I measured these, put them into some variables so that I could easily change them later on, and threw them into a folder so they were tucked out of the way. Created one extrusion, the first block part like that. Then I created a couple more variables. I'm going to use a variable n for the total number of layers I'm going to stack. Layer equals the layer number, and x equals the horizontal distance that this thing can overhang the previous block. Now, this is kind of the setup period of it. From now on, I redo some of the formulas or add a couple of these expressions. And the interesting thing is that you can do with Onshape is that you reuse that name layer, even though we've already defined that. And you can see it's sort of like a iterative thing here. We've got layer equals layer plus one. So that's what this is saying here. Layer equals layer plus one. So then we can loop on this and iterate and increment it. The heart of it is this next equation, this next expression here, which is to calculate the distance that one block has to overhang the previous. And if I look in here, you can see here x equals x plus, because it's the incremental distance. And again, this is a harmonic series, or at least a partial harmonic series, because we're not incrementing, or we're not adding up all of the fractions in the series. We're adding up a certain amount of them. So in fact, if you can have a look at the equation here, you'll see here that this partial sum is basically, you can see in here it's 1 on 2n basically, where n equals the layer number. So it's the sum of 1 on 2n, where n goes to the layer number. Anyway, that's what that equation is doing in here. So you can see here x equals x plus 1 on 2n, and now I just have to, I'm just correcting the n condition here for the layer number. Right, so then having these values, layer equals whatever the increment of layer is, and x equals the increment of the distance that the next block is going to be on, I'm going to copy the block, firstly in the vertical sense, so that's just transforming it by the thickness of the block in according to whichever layer we're in. So again, this is an expression in here, which is thickness, which is one of our specification variables, equals the thickness times the layer number. Pretty easy. And the next one is the heart of it, really, which is the horizontal displacement. And again, it's pretty simple, because it's the x, which we calculated, which is the horizontal displacement, times the length, so that we can get we can have this relative to whatever length that we want. Now, so that's one block. And if I pattern this is where the real key of this all comes in. if I look at this pattern, you'll see it's a feature pattern, and I choose all of the features which are including the ones where I'm doing the increment of the layer number. So if I include this layer equals layer plus 1, then every time I feature pattern on this by this many times, it's going to layer equals layer plus 1, layer equals layer plus 2, layer equals layer, yeah, that sort of a thing. That's the instance count. And the same thing for the X, this X calculation here. I'm going to include this in the pattern, the feature for it, and I'm going to include the 2 transforms as well. So all of those 4 features are included in the pattern. A couple other key things. The instance count is n, the variable. That's how many times the total number of layers we want to get to, in n equals 9 here. The distance, we actually want to put this to 0. You always need a reference direction, but it's not really relevant for this kind of a calculation, so we just need to choose it, choose a distance of 0. What is relevant and what is very important is to use check blocks this apply per instance. And then you can see here that the instance count n is now set to 9. We get this pattern, which is exactly what we want to do. Now, if you examine this, you'll see it's interesting from the top. If this is the top one, this one overhangs by exactly half of the one underneath it. And intuitively, if you only had 2 blocks, in fact, let's set n equals 2 and do this. So this is the beautiful thing with, or n equals 1, so one extra layer. That's what the n means. You'll see that this block will balance exactly on here because its center of mass is right on the edge there. Right? So, assuming that everything is perfect and there's no tolerance and you've got this thing perfectly lined up, this will sit here, exactly here. Now it gets interesting as we add another one to it. So not only does this one have to balance, this one actually has to balance on the base as well. So in fact, this is where that harmonic or partial harmonic series comes in, and it's like 1 on 2, and then 1 on 2 times 2, which is 4. So if you measure the distance from here to here, and you can see down here that this is actually going to be exactly 1/4 of the total length of the block. Right? You can do some expressions to convince yourself of that. It's all, you can do the math basically. Right, so, and in fact, I can just keep adding to it. You can see how this progression continues. I just need to keep fitting it to the screen. So just bring me that to 9 here. So if I actually have created a measure down here, which is measuring the overhang from this point to this point, right? And measuring the x component of that. Oops, this one. If I measure the x component of that, I get 166.485, and I can do the hand calculation and convince myself that this is absolutely correct. The other way that you can convince yourself that this is correct is to just have a look at these parts, which all act as one unit, basically balancing on the base. We look at them and look at the mass properties of it and see where the center of mass is. The center of mass is at 117.7 millimeters relative to the origin, which is this corner, here. So 117.7, which is actually the length of this block, remember? So again, the center of mass of all of the stuff that's highlighted in orange is now exactly perfectly balanced above this edge, so which means it will hang. And in fact, we can continue this. I've got a nice version of it here with 99 stacks, and you can see the shape of this is actually quite interesting. I thought it was quite interesting. Now, the other interesting thing which you can get from that Wikipedia page, of course, and remember your calculus from school days, is that a harmonic series like this, or a partial harmonic series like this, is actually unbounded, divergent, in other words. So if somebody asks, it is possible to create this overhang to span any length possible, just as long as you have enough stack. So if I keep going to 999 or 9,999 books or blocks or whatever you're stacking, it is in fact unbounded as to the distance that we can span. Quite an interesting thing. a very important property of that harmonic series, of course, and I'll let you do some more homework on that. But sometimes you can use Onshape for fun problems like this and revise some of your old math learnings from university days.